Welcome back for the last instalment. Now that we have our model and we're quite confident that it's a very good model, we'd like a way of determining exactly how good this model is. So we're going to calculate the coefficient of determination, R squared. And it's calculated by this formula 1 minus RSS over TSS. Now we already have the residual square sum, so that's fine. But what is this TSS? Well, that's down here. It is the error, not the residual. What's an error? It's each individual y value from over here in our data set, subtract the average of all of those y values. Now it might be worth just calculating the average of the y values. So here we go, using Excel code average and highlighting all of those cells. We have an average of 11.5. Interesting that the vertical displacement translation was also close to 11.5. I wonder if that's a coincidence. So that's that. Now we're going to come over to here and use this first formula about calculating the error. And we'll calculate that by going each individual y value subtracted from the average y value, lock in the y value, and then copy that one down. Now these numbers, if you like, they'll be much bigger than the residuals, but they'll be telling me how much variation there is in the raw data. Again, some positive, some negative. So we square them and then we add them up. So this next column will be the squared differences. Squared. I didn't need anywhere near that many decimal points, which was unusual that it did that. And we'll copy them down. Now let's have our total error summed, squared and summed up here. Just push that one over to the right to fit. And again, we'll use the command sum of all of those. So I have these two values now. RSS is 4.2 and TSS is 1,436. Now up here, a little bit of real estate available up here on my worksheet, I'll calculate the R squared. It's 1 minus the RSS divided by TSS. And that's a pretty good coefficient of determination, showing me that I've got a very high degree of model fidelity. My model is doing a very good job of predicting these values. In some sense, you could say the interpretation of R squared is that 99.7% of the value that the model predicts is due to this time variable. There's a very small leftover bit which is probably due to things I haven't accounted for in my model, such as higher order harmonics like fourth, fifth, and so forth. But I think that with 3 harmonics, I've done a very nice job there, and that's a very high value of R squared, which means I'm quite satisfied with that. And that's the end of this series of lessons on how to use Excel with its solver capabilities, basically getting the computer to do lots of guessing and checking to work out a harmonic model for this type of data, which in this case was a musical instrument. Thanks for watching.